Hey guys, after looking over the worksheet, I think what we're going to do is example 2. We'll do the second one here at the bottom first. It's a little more difficult, I think, than the top problem, so we'll get the difficult one out of the way, and you'll be well on your way to be successful with the other problems on the worksheet. All right, so make sure you understand that the given graph is a slope graph. It's the f prime graph. That's the first big mistake that students do often make. They think this is the function, but indeed it's f prime. Okay, based on this f prime graph, we're going to go ahead and answer the series of questions over here about the regular graph that this is the derivative graph of. And just kind of some things to notice. Notice that you have endpoints on this graph as opposed to the previous problem. So that's kind of important for our problem. Okay, notice that it's made up of a couple of pieces here and then a semicircle and then another piece right here as well. All right, so if we're interpreting from an f prime graph and the question is where is the graph of the function, the regular graph, increasing, you've got that nice graphic organizer that allows you to make connections. Or if f is increasing, then f prime must be positive. So you're actually looking for where this graph is above the x-axis. All these y values are positive, so they were slopes on the regular graph. So where's the graph of f increasing? Where f prime is positive. That's what that means. So look at your f prime graph and just find out where it's above the x-axis, positive y values. So let's answer in a complete sentence. F is increasing on, and it's totally above the x-axis everywhere except for at x equals 1 where it's on the x-axis. So f is increasing on, and let's count, 1, 2, 3, negative 4. So it's increasing on negative 4. Okay, now I can go ahead and include 1 here because even though we have a 0 slope, a graph can still be increasing at a 0 slope. So I'm going to go ahead and just extend over to 3. But we're going to be careful in our justification. So f is increasing from negative 4 to 3 because f prime is greater than 0. But remember, at one point right here, it was also equal to 0. So we'll fix that real quickly and just put greater than or equal to 0. All right, where's the graph decreasing? Well, f is decreasing where the slopes are negative. Okay, so decreasing means f prime is less than 0. Well, this is an f prime graph we're looking at. So the function is decreasing on, and I see that it does decrease on 1, 2, 3, 4, negative 5. This is the point negative 5. It appears to be negative 2. Okay. The graph is decreasing on negative 5. I'm going to go ahead and include that with an endpoint here. I'm going to include it with a bracket because that negative 5 right there is below negative number. So I know the function is decreasing on negative 5. It would be certainly fine if you put a parenthesis here too, but I think it's kind of important to note that you do want to include negative 5 as a y value that's less than 0. So negative 5 up to negative 4. I'm going to use a parenthesis here. And it looks like at 3 to 4, and I'll put a parenthesis here on the 3 and a bracket on the 4. Okay, I want to try and avoid the zeros, but 4 is definitely below the x-axis. Okay, because... And here we can just simply say because f prime is less than 0. So to answer these questions, you're actually looking for where the graph of f prime is above or below the x-axis. Does the function have any relative extrema? If so, where? Justify your answer. Okay, well, we're looking for x-intercepts. Right here and right here. And of course, this is an x-intercept, but specifically for where the graph of f prime changes from positive to negative. It cuts through the x-axis, if you will. So I'm going to start over here at x equals negative 4. F has a relative, and I'm going to leave this blank for a minute, at x equals negative 4 because f prime, this graph changes or goes from, if you want, changes from what? Well, this graph is going from underneath the x-axis to above the x-axis. So it goes from negative to positive, changes negative to positive. So think back or look at your graphic organizer. If your slopes go from negative to positive, that means your function's going from decreasing to increasing. You have a min. So we have a minimum here, so this must be a maximum. Because f prime changes or goes from, however you want to word it, changes. The slopes go from positive to negative. F prime changes positive to negative means the function has to go from increasing to decreasing. All right, 3. Where is the graph of the function concave up? Well, we do have, remember that little fun acronym to remember about concavity on a function? Remember, there's 2 justifications. A graph can be concave up if the second derivative is positive, but we could also say because f prime is increasing. Well, if I'm looking at an f prime graph, I'm probably going to go with that justification instead of the f double prime justification. If I was working with an equation, I'd find the second derivative and then work from the second derivative justification. But because I have f prime, that's the route I'm going to go. All right, where is f concave up? Well, that would be where f prime is increasing. Okay, so we're going to look over here at the graph. Now it's not simply about where it's above and below the x-axis. It's actually looking at the graph and figuring out where it's rising and falling. So let's take a look over here. F prime is increasing. That means the graph of the function is concave up. F is concave up. F prime is decreasing. It continues to decrease. It continues to decrease until we get to here. So that means that the function is concave down. Then for a little bit of time, the graph is concave back up, because f prime is increasing. And then the graph of f prime is decreasing, so the function is concave down. All right, so let's see if we can put this together. The question is concave up. F is concave up on, it looks like -5 to -3. Always parentheses on concavity. Always parentheses, never brackets on concavity. It also increases again from 1 to 2 because f prime is increasing. And if you think about it, the slopes to this graph, where this graph is increasing, would be positive, and that would just be your f double prime values. Okay, where is f concave down? F is concave down on, where is it falling? From, I guess it's -3. It's still falling right here through that sharp turn. That's okay. From -3 to 1. And I guess it falls again from 2 over to, I think that was 4. Put parentheses, not brackets, always on concavity, because f prime is decreasing. Does the function have any points of inflection? Well, it has to if the concavity changes, and if so, where? All right, well, to answer this question, it's where f prime changes direction. So that would be your relative mins and maxes. So maybe if I went to a different color and shared that, okay? So, that's a max, dropping, dropping, dropping. This is a min. This is a max. Okay, so a min and max on the f prime graph are your points of inflection. Okay, so I'll go back here. So I'm going to just put f has, I'm going to lump all this together. POIs at, I guess it doesn't like me to change the color. X equals -3, 1, and 2 because f prime changes direction. And you might want to, on the other problems that you're going to be doing, the extra problems here, you might want to actually pick these apart. You might want to just take and represent each of them individually so that you can specifically say that at x equals -3, f prime changes from increasing to decreasing. And then at x equals 1, f prime changes from decreasing to increasing. You could probably lump these two together, because f prime changes from increasing to decreasing at both those locations, and that'd be fine. And then perhaps do an explanation of that one separately. I'm certain you'd get full credit for this explanation, but I think it'd be good practice to separate them out as well. Anyway, hopefully you found that this was helpful for you, and the other 4 will go pretty quickly. All right.